Okay, in this problem, we are being asked to find the slope, the y-intercept, and the y-intercept of this equation, negative 10x plus y equals 3. Now, if you're looking at this equation, you may see that this equation is in standard form because as x and y are on the same side of the equation, we want to write it in slope-intercept form so we can see clearly what's the slope and the y-intercept is. So the process includes adding 10x on both sides of the equation. So that cancels 10x on this side, and y equals 10x plus 3. Now, the slope of the equation is 10, or if you want, that's 10 over 1, if you want to be precise in terms of y is over 1. But you have to know also that in MyMathLab, you can't plug in 10 over 1 because MyMathLab knows that when 1 is the denominator, you don't have to write it. So it's 10, and the y-intercept is 0,3. Now it's not 3, it's 0,3. So if you put 3, you lose the point. Next problem, find the slope of the line x equals 8. We've seen that when the equation does not show x and y, x or y, there are some particularity that we need to know, that if the equation doesn't show y, this equation has a slope undefined, and it is a vertical line. So the equation does not show, the equation shows only, let me say that instead, it shows only x therefore the slope is undefined. Shows only x, therefore the slope is undefined. And then for the next problem here, you will say something similar to that because I'm seeing only y. The equation shows only y. And it's a similar question to this one. It says find the slope of the following line, y equals 12. The equation only shows y, the y variable. Therefore, the slope is 0. So if it's only y, the slope is 0. And if it's only x, the slope is undefined. Over here, we have this graph, and we are trying to find the value of f of 0. So they are giving me the input 0 that I can find on the x-axis, 0 equal x equals 0. And then we want to try to find a way to touch the graph from this value of x, 0. And then after we touch the graph, we will find the y value corresponds to the location at which we hit the graph. So in this case, we hit the graph at y equals -2. So f of 0 equals -2. It's that simple. Next problem, same type, it's the only difference is that they give me the graph and they want me to find f of 2. Now x equals 2, try to touch the graph. Now the y value at which we touch the graph, we're going to try to find it. It's -5. It's -5. So f of 2 equals -5. At the same time, if they give me the output, if the output is given to me, so I can find the input corresponding to this output. So f of x equals -5. So on the y-axis, I'm looking for -5 right here. From that, I'm going to touch the graph and then try to find the x value at which we touch the graph. What's the x value? So f of x equals -5. I move up and then I touch the graph at this point, and I want to find the x value for x, the x for which I hit the graph. So f of x equals -5. We want to go in the horizontally and then touch the graph and then bounce back to the x-axis. And then we find that the x value at which we hit the graph at y equals -5 equals -2. So f of x equals -5 gives me x value equals -2. So we want to simplify number 1330. We want to simplify this fraction. Now we want to make sure we watch for negative exponents. So the property for negative exponent, the negative exponent property, the negative exponent property, it says if I have a exponent -n, it equals to 1 over a exponent n, switch the negative sign to a positive, but we transform this expression to a positive exponent, to a fraction. Or if you have the negative exponent in denominator, so you would have a exponent negative a, you have something like 1 over a to the negative exponent n. So that will transform this into a exponent n. So you don't want to keep a negative exponent with this property. So this property allows you to be able to transform your expression with a negative exponent to a positive exponent. So let's look at this. We're going to try to simplify first in numerator and denominator. Then we will start to work with both of them together. So we're going to keep 6 and then z exponent -7 plus 5 is -2 over z to the -2 power. Now this property, if I have the same variable raised to the same exponent both in numerator and denominator, it reduced to 1. So that means the circled part of this expression, z to the -2 power over z to the -2 power, is 1. So that's 6 times 1. This equals 6. Whenever you have the same exponent both on top and on the bottom, it cancels out to 1. and then it automatically give me this answer here, that is 6 times 1 equals 6. Now, what do we see here? We see some negative exponents. So we're going to try to work with them. But first, let's do the numbers, the coefficient. 15 divided by 3. 15 divided by 3 will be 5. Now, let's work with each variable separately. X to the -6 power, and on numerator and denominator is 4. Now, you want to move the smallest exponent to wherever the highest exponent is for the same variable. Now, I say it's for any variable that you work with. So if you have the highest exponent on top, you move the smallest to the top. If you have the highest in denominator, then the top will be sent over to the denominator. Now, in this case, x to the power -6, x to the power 4. Power 4 is greater than power 6. So we're going to keep x in denominator. And then we move this one to the bottom. So that'll be x to the -6. -6 changes to a positive, because if you move from top to bottom, it changes it was negative, it changes sign. So from negative to positive, or from positive to negative, depends on, you don't need to move a positive anyways, unless it's smaller than the other one. And then now you have the 6, because it moves to the denominator, and then plus 4, so that's x to the 10th power. When you move the 6, it changes sign. And then what do you see for y? The y's have the same exponent, they cancel each other. And the z to the -4th power, and then z to the first power. -4 is smaller than 1, so z goes to the denominator, and 4 changes sign to positive. 4 plus 1 is 5. So that answers this question right here. Over here we have 0.00032. Now we're converting from a standard to scientific notation. So, you know, scientific notation, what you need to remember is it's always in the form of a times 10 exponent p. A times 10 exponent p, where p is an integer. P is an integer. And then a is a number that should always be less than 10, and then the smallest it can be is 1. Now, if you have a number that is smaller than 1, you better play with it to make it between 10 and 1. And the only tool that you have is to move the decimal. And the number of times you move the decimal would be the power that you give 10. That will be the p-value. If you move it to the, but if you have a number in standard form that's smaller than 1, your exponent is always going to be negative. P is negative when the number is smaller than 1. So in this case, your exponent P is going to be a number smaller than 1, but it corresponds to the number of times you move your decimal. So that's 1, 2, 3, 4. Because if I move it to the 5th position, that's going to be after the 2. That will give me automatically 32, which is bigger than 10, still problem. So you want to keep it in between 2 and 3, which gives me a 4 moves. 4 moves tells me how much the power is going to be, since it was a number smaller than 1, and then it's going to be a negative exponent. So that's 3.2. That's where I stopped between 2 and 3 times 10 exponent -4, the number of time I moved the decimal. And now if you have it in standard form, in scientific notation, you can always do the same thing to make it to transform it in standard form. So you're gonna, now 8 is the number of time you're gonna need to move your decimal. You're gonna move it to the right. So that means 1, 2, 3. 3 times I moved it, but I still have 8 moves. So I still have 5 moves left, right? And no more numbers. Well, I'm gonna put zeros for the remaining moves. So that's going to be 6,176. And then the rest 5 zeros, I add them after the number. More exponent property. Now this one, you can see that -2 is an exponent and only fraction and multiplication inside. So I can distribute this negative to be the power, to multiply the powers of each variable or expression, factor, I would say, inside of the parentheses. So that will give me x to the power -9 times -2, 18, -8 times -2, 16, and then -4 times -2, 8. So that is the answer for that. I just distribute the power. It multiplies and change everything to positive, which solves all the problem that I could imagine. So that makes it exactly how I want it. So this one was easy. Now this one here, let's do the same thing. We're going to apply the negative exponent property. 7 to the -1 power will move. I will move it to the bottom. That will be a +1 exponent that I don't have to write. And also we're gonna measure which variable has the smallest exponent or negative, and then we're gonna move them to the opposite side of the fraction. So we have x to the power -3, and the top one is +5. So x is going to move up, the -3 will change to positive, and then they add to 5. So that gives me x to the 8th power. Done with x, let's see what we have for y. The y's have same exponent, they cancel to 1, and then we will try to work with the z variable. The z variable, look at it right here. What do you see? The top one has no exponent, means exponent 1. The bottom one has an exponent 3. Which one is bigger? Well, the z exponent 3 has a 3 exponent bigger than the 1 exponent. So the z exponent 1 will be moved to denominator, but exponent 1 changes to exponent -1 when we move it and subtract the 1 from 3. So that gives me a z to the power 2, because 3 minus 1 is 2. So that's it for this one. Okay, over here, number 36, what I'm looking at is that I should multiply two numbers that are in scientific notation. First, to multiply scientific notation number, you multiply the a values, the numbers before the multiplication sign. So that gives me 5 times 2.2. Let me put the multiplication sign instead. So that's 5 times 2.2. And then the power 10 exponent 15 minus 5. So that's 10. And then now let me perform this multiplication. So 5 times 2.2, do it with your calculator, but it should be 11 times 10 exponent 10. Now you got to be careful, because what's going to happen is that you're going to think that you're done, which is not. And at this point, you still not have your credit. You're looking at 11, which is bigger than 10, and they are asking me to give my answer in scientific notation. So I want to make sure that I convert my expression, my final expression in scientific notation. So the scientific notation requires that the number that comes before the multiplication sign or before the power of 10 should be greater than 1, or equal 1, but less than 10. This one is greater than 10. So how do you do? You're going to have to take the decimal point, move it here so that you have a number that is a value that is smaller than 1, than 10. And then when you move it here, you want to preserve the value of your number by changing it into 11 power. You add a power because you moved it once. If you don't do that, then you are in trouble. Okay, so combining like terms to add, subtract, and multiply polynomials. Well, let's see it. So what we do here, we're gonna watch this. What sign is it? Negative. The negative sign outside of a pair of parentheses will change the sign of everything inside of the parentheses that's being placed after the sign. After the sign. Before the sign, don't worry about it. You just drop the parentheses. So that's 5y squared minus 9y plus 1. And then the negative sign switches the sign of everything after. So that's negative 9y squared plus 9y and then minus 5. And then left, the next thing you do is to combine like terms. So we got 5y squared minus 9y squared. That is going to be negative 4y squared. Negative 9y plus 9y, that's 0, and it's gone. And then plus 1 minus 5 is negative 4. That's my answer. If you want to factor it, don't worry about that. Don't do it. Next problem here, we have to multiply two polynomials, but one is a binomial and the other one is a trinomial, right? So to do that, we're going to think about distribution. So first, let me take the first term of the binomial that will multiply by every term of the trinomial. And same thing will happen here with the second term of the binomial. Let's start with the first term of the binomial. We do negative 9x times x to the third, that's negative 9x to the fourth. Negative 9x times negative x is positive 9x squared. Negative 9x times negative 9, that's positive 81x. Done with the first term of the binomial. Multiplies all the three terms of the trinomial. Now, we want to do the same thing with the second term. 9, which is 9. 9 times x to the third, that's plus 9x to the third. 9 times negative x, that's negative 9x. And 9 times negative 9 is negative 81. Then now we can combine like terms and then problem solved. So let's see. There's no like for 9x to the fourth. I just write it out. I'm gonna put it in order. So I go with the 9x to the third, which does not have a like term. I just write it out as well. X to the second has no like. So that's plus 9x to the third, second, sorry. And then combine like terms for 81x and negative 9x. That's going to be plus 72x and then minus 81. And that is your answer for this question. So as you can see here, I have this problem twice because they didn't tell me how to solve it. Well, actually they did. But I do want to show you two ways of doing it. And then you don't want to do the second way because it's gonna mess up with your time. And then there is a quick way to do it. And then they tell you to do it this way, actually. They say multiply using the rule of product of the sum and difference of two terms. Product of the sum and difference of two terms. Product of the sum and difference of two terms is the difference of their squares. A plus B times A minus B equals A squared minus B squared. The product of the sum and the difference of two terms is the difference of their squares. Is the difference of the squares of these two terms. So that said, that's going to be 7x squared minus 8 squared. See how easy is that? And some of you may ask, why does he put parentheses with the first group for first term and then the second one, no parentheses? Try to answer that. Well, the first term is two factors. And I want you to know that when you square a term that has 2 factors, 3 factors, 4 factors, a number of factors, the power is also power for all the factors. That's why I put parentheses for you to know that the power will be served for all the factors, which means that's 49 and x squared minus 64. So that's it. But the second one is FOIL, which all of you know, that's going to be, you distribute the 7x over the 2 terms over, and then you do the same thing for the 8. So that's 7x times 7x, 49x squared. 8 times 7x, that's 8 times 7 is 70. Oh wait, 70. Yeah. Oh, 60, 53. Is it 53? Okay. You're sleeping. Oh my God. Let me do it here. 7 times 8. So that 56. You see, glad I did it. So that's positive 56x. 56x, and then another negative 56x, and then that's negative 64. These cancel each other. That's 49x squared minus 64. So you find the same answer, but more work. So I would say go with the product of the difference of two terms. The sum and the difference of two terms. Product of the sum and the difference of two terms. So this one is another way of solving the problem. That's why I changed the color. Now this one, you can use the FOIL method, but there is a formula that says if I have A plus B squared, it equals to A squared plus 2AB plus B squared, or if it's a negative sign, that's A plus minus B squared equals A squared minus 2AB plus B squared. But if you don't remember that, I don't want you to force your brain to remember. Just do FOIL here. So that's 10x minus y times itself, 10x minus y, and then distribute. That's 100x. That is negative 10xy. That's going to be another negative 10xy, and then that's positive y squared. So that simplifies to 100x minus 20xy plus y squared. Over here, that's the plus case for the formula that I gave you. You can use it, or you know what? I'm not going to do FOIL for this one since you understand the FOIL and I've done one. So let me go ahead and just do this formula for it. So the A here is 4x squared minus 2 times the A again, 4x times the B, which is 5, and then plus 5 squared, and then perform the work to get the final answer that is 16x squared minus, that's 40x, and then plus 25. That's the answer for you. And over here, we're going to use FOIL, or let me use the difference of the product of the sum and the difference of two terms. The product of the sum and the difference of two terms is the difference of the square of the two terms. Difference of the squares of the two terms. So this one squared, 3v squared, minus this one, 4v, 4t squared. And then simplify, that's 9v squared minus 16t squared, and that's your answer. And then that one, this problem 43 will be solved in the previous video. So remember, the other one was from 1 through 23, and then we had to skip, was a mistake, and then started all the way over to 43. Now you have the middle part. Enjoy it, and then any question, you know that you have to send it, and then I'll see you next class.